Our planet is a water world. Oceans cover over 70% of Earth's surface. These vast bodies of water are in constant motion. Waves crash against the shore, currents flow across vast distances, and tides rise and fall. But what causes these tides? The answer lies with our celestial neighbor, the moon. The moon might seem distant and insignificant compared to the vastness of our oceans. However, its influence on Earth is undeniable. The moon's gravity is the primary driver of the tides we experience here on Earth. This gravitational force creates a fascinating interplay between the moon and our oceans. Gravity is a fundamental force in the universe. It is one of the four fundamental forces that govern the interactions of matter and energy. Without gravity, the universe as we know it would not exist. This force is responsible for the formation of stars, planets, and galaxies. It is the glue that holds the cosmos together. Gravity attracts objects with mass towards each other. This attraction is what keeps us grounded on Earth and what causes objects to fall when dropped. The famous story of Isaac Newton and the apple illustrates this perfectly. When the apple fell from the tree, Newton realized that the same force that caused the apple to fall was also responsible for keeping the moon in orbit around Earth. The moon exerts a gravitational pull on Earth, and this pull is what causes the tides. The gravitational force of the moon pulls on the Earth's oceans, creating a bulge of water on the side of Earth facing the moon. This bulge is what we experience as high tide. This force is invisible to our eyes, but its effects are clearly visible in the rhythmic rise and fall of ocean levels. The tides are a daily reminder of the moon's gravitational influence on our planet. As the Earth rotates, different areas experience high and low tides, creating a dynamic and ever-changing coastal environment. The moon's gravity pulls most strongly on the side of Earth that is closest to it. This creates a bulge in the ocean water on that side of Earth. But the story doesn't end there. The gravitational pull of the moon also affects the opposite side of Earth. This pull creates a bulge in the ocean water on that side of Earth. This bulge is what we experience as high tide. However, there is another high tide on the opposite side of Earth, caused by the inertia of the water as the Earth and Moon system rotates. This bulge is what we experience as high tide. The interplay between the gravitational forces of the moon and the rotation of the Earth creates two high tides and two low tides each day. This phenomenon is known as the tidal cycle. But here's the interesting part. There's another bulge on the opposite side of Earth. This second bulge is caused by the centrifugal force created by the Earth-Moon system's rotation. As the Earth rotates, the water on the side opposite the moon is flung outward, creating a second high tide. This dual bulge system is a fascinating example of the complex interplay of forces that govern our planet's natural phenomena. Understanding the invisible hand of gravity and its effects on our planet helps us appreciate the delicate balance of forces that shape our world. From the formation of galaxies to the daily rise and fall of ocean tides, gravity is a fundamental force that influences every aspect of our lives. It is a reminder of the interconnectedness of the universe and the intricate dance of celestial bodies that govern our existence. While the moon's gravity pulls strongly on one side of Earth, it also pulls Earth itself away from the water on the opposite side. This creates a second bulge, resulting in high tides on both sides of our planet. Between these two bulges are areas of lower water levels, which we experience as low tides. As Earth rotates on its axis, different locations pass through these tidal bulges. This is why most coastal areas experience two high tides and two low tides each day. This regular cycle of tides is a testament to the powerful, yet invisible force of gravity. While the moon is the primary driver of tides, the sun also plays a role. The sun's gravity also exerts a pull on Earth's oceans. However, the sun is much farther away than the moon, so its gravitational effect on tides is weaker. When the sun, Earth and moon are aligned, their combined gravitational forces create more extreme tides. These are known as spring tides. Spring tides occur during new moons and full moons. On the other hand, when the sun and moon are at right angles to each other, their gravitational forces partially cancel each other out. This results in less extreme tides, called neap tides. One might assume that high tides occur precisely when the moon is directly overhead. However, there is a slight delay between the moon's position and the occurrence of high tide. This delay is known as tidal lag. Tidal lag is primarily caused by Earth's rotation. The moon's gravity pulls the tidal bulges slightly ahead of its own position as Earth rotates. This lag can vary depending on the location and the shape of the coastline. Understanding tidal lag is crucial for predicting tides accurately. Section 6. The range of the tides. The difference in height between high tide and low tide is called the tidal range. This phenomenon is a fascinating aspect of our planet's natural rhythms, driven by the gravitational forces exerted by the moon and the sun. The tidal range is not just a simple rise and fall of water levels, it is a complex interplay of celestial mechanics and Earth's own characteristics. This range can vary significantly depending on the location. For instance, some coastal areas may experience a tidal range of just a few feet, while others can see changes of several meters. The variation is influenced by multiple factors, making each coastal region unique in its tidal behavior. Factors such as the shape of the coastline play a crucial role. A coastline with a funnel shape can amplify the tidal range, causing higher high tides and lower low tides. This is because the narrowing of the coastline forces the water into a smaller area, increasing the height of the tide. The depth of the water is another significant factor. Shallow waters tend to have a more pronounced tidal range compared to deeper waters. In shallow areas, the water has less space to spread out, so the rise and fall of the tide are more noticeable. The position of the moon and sun also influences the tidal range. When the sun, moon, and earth are aligned, we experience spring tides, which have the highest tidal range. Conversely, when the sun and moon are at right angles relative to earth, we experience neap tides, which have the lowest tidal range. Some places, like the Bay of Fundy in Canada, experience incredibly dramatic tides. The Bay of Fundy is renowned for having the highest tidal range in the world, making it a prime location for studying tidal phenomena. The Bay of Fundy has the highest tidal range in the world, with a difference of up to 15 meters between high and low tide. This dramatic change is a sight to behold and attracts tourists and scientists alike. With a difference of up to 15 meters between high and low tide, the Bay of Fundy offers a unique opportunity to observe the power of tidal forces. The extreme tidal range is not just a natural wonder, but also has practical implications for local ecosystems and human activities. This incredible range is due to the unique shape and size of the bay, which amplifies the tidal effects. The bay's funnel-like shape and its resonance with the natural tidal period of the Atlantic Ocean create a perfect environment for such dramatic tides. The amplification of the tidal effects in the Bay of Fundy is a result of a phenomenon known as tidal resonance. This occurs when the natural frequency of the bay matches the frequency of the incoming tides, leading to a significant increase in tidal range. This natural amplification is a fascinating example of how geography and celestial mechanics can interact to create extraordinary natural events. The dramatic tides of the Bay of Fundy have a profound impact on the local ecosystem. The intertidal zones, which are areas that are underwater at high tide and exposed at low tide, are teeming with life. These zones provide a unique habitat for various species of plants and animals, which have adapted to the changing conditions. Human activities in the Bay of Fundy are also influenced by the tidal range. Fishing, for instance, is heavily dependent on the tides, as many species of fish move with the changing water levels. Tourism is another significant industry, with visitors coming from all over the world to witness the dramatic tides and explore the unique landscape. The Bay of Fundy has been significant throughout history, not just for its natural beauty, but also for its economic importance. The dramatic tides have shaped the way of life for the communities living along its shores, influencing everything from fishing practices to transportation and trade. In conclusion, the range of the tides is a complex and fascinating aspect of our natural world. From the subtle changes in coastal areas to the dramatic shifts in places like the Bay of Fundy, tides play a crucial role in shaping our environment. Understanding the factors that influence tidal range helps us appreciate the intricate balance of forces that govern our planet's oceans. Thank you for watching this segment on the range of the tides. Stay tuned for more educational content on the wonders of our natural world. The moon doesn't orbit Earth in a perfect circle. Instead, its orbit is slightly elliptical. This means that the moon's distance from Earth varies throughout its orbit. When the moon is closest to Earth, its gravitational pull is stronger, leading to higher than average tides. Conversely, when the moon is farthest from Earth, its gravitational pull is weaker, resulting in lower than average tides. This variation in the moon's distance contributes to the complex patterns of tides that we observe. Tides are more than just a fascinating natural phenomenon. They play a crucial role in shaping coastal ecosystems. The rise and fall of tides create unique habitats like intertidal zones, which are home to a diverse array of plant and animal life. Tides also influence ocean currents, which are vital for distributing nutrients and regulating Earth's climate. Understanding tides is essential for navigation, fishing, and coastal management. The rhythmic rise and fall of tides have captivated humanity for centuries. This mesmerizing dance of the ocean has been a source of inspiration, mystery, and scientific inquiry. The tides are not just a simple rise and fall of water levels, they are a complex interplay of gravitational forces and celestial mechanics that have profound effects on our planet. From ancient mariners to modern scientists, we have sought to understand the forces that drive this natural phenomenon. Early sailors relied on their keen observations of the tides to navigate treacherous waters, while modern scientists use advanced technology to study the intricate details of tidal movements. The quest to understand tides has led to significant advancements in our knowledge of the Earth's systems and the universe. The Moon's gravitational pull, combined with the interplay of Earth's rotation and the Sun's gravity, creates the complex and fascinating dance of the tides. This gravitational ballet is a testament to the interconnectedness of celestial bodies. The Moon, our closest neighbor in space, exerts a powerful influence on our planet, causing the oceans to bulge and creating the high and low tides we observe daily. As our understanding of the universe expands, so too does our appreciation for the interconnectedness of all things. The study of tides has revealed the delicate balance of forces that govern our world. It has shown us that even the smallest changes in gravitational forces can have significant impacts on our environment. This knowledge has deepened our respect for the natural world and our place within it. The tides serve as a constant reminder of the powerful yet invisible forces that shape our world. They influence coastal ecosystems, affect weather patterns, and even play a role in the Earth's rotation. The ebb and flow of the tides are a natural rhythm that connects all living things to the cosmos. They remind us of the dynamic and ever-changing nature of our planet. They are a testament to the beauty and wonder of the cosmos, and a source of endless fascination for those who pause to observe them. The sight of the ocean's tides can evoke a sense of awe and wonder, reminding us of the vastness of the universe and our small place within it. Whether we are scientists studying the mechanics of tides or simply beachgoers enjoying the view, the tides connect us to something greater than ourselves. They are a never-ending story of motion and change, a reminder of the eternal dance of the cosmos.